Imagine a missile that flies so low it literally hides from radar and then accelerates to 3 times the speed of sound to strike with pinpoint accuracy. Welcome to the channel.
What we just described, that is not science fiction. It's the BrahMos, India's premier supersonic cruise missile that has legitimately become a global defense sensation. Here is our roadmap for today. 1. The BrahMos joint venture. 2. Cruise versus ballistic missiles. 3. Inside the Ramjet engine. And 4. Versatile operational variants. Let's jump right into part 1, the BrahMos joint venture. So where did this high-precision powerhouse actually come from? Well, it's born from a joint venture between India's DRDO and Russia's NPO Mach. And fun fact, the name itself is a portmanteau. It cleverly combines the names of 2 rivers, the Brahmaputra in India and the Moskva in Russia. And if you look at the ownership, it's split almost right down the middle, with India holding a 50.5% share and Russia holding 49.5%. Now let's talk facts and figures. And 3, that's the magic number. The BrahMos achieves a top speed of Mach 3. That is 3 times the speed of sound. At those literally supersonic speeds, an adversary's reaction time is practically reduced to 0. There's just no time to blink. But it's not just about raw speed, it's also about reach. 350. While the original design had a 290-kilometer range, the extended range versions can now pinpoint targets up to 350 kilometers away. And to put that into perspective, it's doing all of this while delivering a massive 200 to 300 kilogram conventional warhead. So how exactly does it reach its target without getting swatted out of the sky? Well, it's all about the flight profile. The missile cruises comfortably at high altitudes, up to 15 kilometers in the sky. But here is the real kicker. As it approaches the target, it suddenly drops, skimming the Earth at a terminal altitude of as low as 10 meters. It's practically hugging the ground. This ultra-low radar signature is exactly what makes the BrahMos exceptionally stealthy. Moving right along to part 2, cruise versus ballistic. First, to really grasp what we're dealing with, we need to understand that the BrahMos is what's called a standoff range weapon. Simply put, this means it's fired from a considerable distance, which allows the attacker to completely evade enemy defensive fire. Basically, you launch from safety, and the missile navigates the danger zone for you. And when we compare our cruise missiles, like our BrahMos here, against ballistic missiles like the Agni or Prithvi, we're looking at fundamentally different physics. I'll slow the pace down a bit so we can really compare them. A cruise missile is jet-powered throughout its entire flight, much like an airplane. A ballistic missile, on the other hand, is powered only briefly during launch, essentially coasting on a projectile path. Because of that continuous power, the cruise missile maintains a low, highly maneuverable trajectory. Meanwhile, the ballistic missile arcs high up into the atmosphere. So, naturally, the low-flying cruise missile is incredibly hard to track below the radar horizon, while that high-arcing ballistic missile is much, much easier to detect. All right, part 3. Inside the Ramjet engine. Now, the BrahMos doesn't just use one engine. It's actually powered by a brilliant 2-stage propulsion system. Stage 1 is a solid propellant booster. Its one and only job is to violently kick the missile off the launcher and accelerate it right up to supersonic speeds. Once it gets going fast enough, that solid booster just falls away, and Stage 2 takes over, and that is the liquid ramjet engine. So how does a ramjet actually work? Unlike a standard jet engine on a commercial plane, a ramjet has literally 0 rotating compressor blades. It relies entirely on its own speed. Let's break it down. Step 1, it uses the extreme forward motion of the missile to physically ram and compress the incoming air. Step 2, liquid fuel is injected directly into this highly compressed, high-speed airstream. And step 3, it ignites this mixed hot air to produce massive continuous thrust. It's an incredibly efficient design, but remember, it only works because that first-stage solid booster pushes it to supersonic speeds to begin with. The specific ramjet used by the BrahMos is highly efficient at supersonic speeds, right around that Mach 3 mark. But if you want to go faster than that, the efficiency drops off. That is where a scramjet comes in, allowing for combustion at hypersonic speeds. Then there's the dual-mode ramjet, which actually transforms from a ramjet into a scramjet as speeds cross Mach 4 to 8. But for the incredibly reliable Mach 3 performance of the BrahMos, the standard liquid ramjet is absolutely the perfect tool for the job. Which brings us to part 4, versatile operational variants. Let's look at how this beast is actually deployed in the real world. First, we have the surface variants. For naval operations, the ship-based systems can be fired either vertically or inclined. and they're capable of unleashing devastating salvos of up to 8 missiles simultaneously. On land, the system utilizes mobile autonomous launchers. Each of these holds 3 missiles, and this incredibly mobile land attack version has been operational since 2007, constantly shifting positions to avoid being targeted.
Then we have the air-launched cruise missile variant, or the ALCM. Honestly, this version is an absolute beast. It is literally the heaviest missile to arm the Sukhoi 30 MKI fighter jet. I mean, just imagine the tactical advantage here. A high-speed fighter jet carrying a Mach 3, 350-kilometer range supersonic sniper rifle.
And finally, there is the stealthiest variant of the whole bunch, the submarine-launched BrahMos. This iteration can be fired vertically from a canister hidden roughly 50 meters below the surface of the ocean. Think about that. An adversary wouldn't even know the submarine was there until the water suddenly erupted with a supersonic missile hurtling straight toward them. So, where do we go from here? Well, the BrahMos system is continually evolving, with a next-generation version, the BrahMos-NG, currently under development. With its reduced weight, vastly improved stealth profile, and the potential to be launched directly from standard submarine torpedo tubes, we have to ask, how will the futuristic BrahMos-NG fundamentally alter global naval warfare? It's a massive question, and one that defense analysts around the world are watching incredibly closely. Thank you for watching.